That's right, wireless redstone in Minecraft. But what does that even mean? Well, you can see here, I have two machines. There's no physical connection between them, yet when both of them are on, and I press this button right here, you'll see that eventually it comes up on the screen, and it will also show up on this screen. I have not used command blocks or mods or done any weird editing to achieve this. So what have I been doing? Well, a while ago, Psycraft member 2NoToName discovered a method of wireless redstone signaling through the manipulation of entity IDs. I'll leave his explanation of the mechanics in the description, along with a more in-depth video covering a lot of Minecraft's weird update order by iPlayGames. In essence, Minecraft items dropped on the ground will all have their own ID to them, and this ID actually affects how they update their physics. So if I open up all these trapdoors, you'll see that the items are actually offset a little bit. They don't all fall down at the same time. They're actually offset by one tick from each other. And this is because of how that system works. It was an optimization added in 1.13. I'll let you watch those other videos to figure out exactly what is happening. To use this in wireless redstone, what we do is we create two items in the same tick, offset by one ID each. So they're going to be right next to each other in terms of ID. So let's say ID 100 and ID 101. That's not what they look like, but we'll just stick with that. When they update, they're going to update one tick apart. So you'll see my comparators here. They're going to light up one tick apart from each other, right? And that'll turn off the torch for sure, but it won't turn off this lamp because this lamp needs 4 game ticks to turn off. When our items come here, they're going to update one tick apart. Both of these repeaters are going to turn on for 2 ticks because that's how repeaters work. But since they're offset by 1 tick from each other, the total time, because the repeaters will overlap, this torch will turn off for 3 game ticks, not 4 game ticks. We need 4 game ticks for this to turn off. But if I were to send an item through by creating one such that it offsets one of the items there and actually makes them update 2 ticks apart, well, now our repeaters aren't overlapping each other anymore. So this torch will turn off for 4 game ticks, which gives enough time for the lamp to turn off and the observer to detect that and activate the command block, as you saw in chat right there. You might be wondering though, how am I syncing up my items so that they're gonna perfectly offset one of the receiver's items by 1, but leave the other the same, so that we have that 2 tick gap? Well, I introduce to you the daylight detector, or sensor, whatever it's called. What is it? Daylight detector. Yeah, there we go. These things are basically never used in actual redstone. That's because they're actually pretty unreliable for the one purpose that they were actually added for, which is telling the time. You see, daylight detectors get affected by rain, they get affected by different blocks in the surroundings. It gets messy. So daylight detectors, not a great use. But for wireless redstone, they've got one specific trait which is super useful. You see, every daylight detector in your Minecraft world, no matter where, will update at exactly the same time, every 20 game ticks or every second. So, every 20 ticks your Minecraft world is running, it will update all daylight detectors as long as they're loaded. This means that we can get 2 synchronized clocks anywhere in the world just by using daylight detectors. So if I activate this redstone clock, yeah, it's going there. And then it doesn't matter when I break this block to activate the second clock, it'll sync up with that one right there. So if I break it there, look at that, perfectly synced up. Now, there are other ways to sync up your clocks, methods which would also happen to work in other dimensions, but I just stuck with daylight detectors since they're the easiest. And why are you making TicTacToe in the nether? Tell me. Another thing is, what if I wanted to have more wireless redstone in my world? I don't want them interfering with each other, but if they're all synced up to the daylight sensor, then they're going to interfere, aren't they? Well, not quite. For each wireless contraption you have in your world, you can essentially separate them from each other by assigning them what is basically an IP address. Now, what I thought this was Minecraft, not like networking. So what do you mean by IP address? Well, it works the same way as it does in real life. You assign each machine a specific code, and that tells your network where to send what data. We can do the same thing in Minecraft by encoding through these repeaters here, these strings of 4 repeaters. So for instance, this machine, this TicTacToe machine here, has an IP of 1, 1, 1, 1. Alright? 1, 1, 1, 1. Remember that. Now, if I come over to the second machine, this one has an IP of 1, 1, 1, 2. Okay, so these two machines are distinct from another. They do have a different IP, but how do they communicate? Well, when we're transmitting a signal, we have 1, 1, 1, 1 down here. So this would send the signal to that. And over here, we have 1, 1, 1, 2. So this will send the signal to this one. Simple. So we can use IP addresses to separate our machines from one another, and also coincidentally separate them from any other wireless system you have in your Minecraft world. Anyways, now that we have wireless tech out of the way, let's get back to tic-tac-toe. Why did I want to make a tic-tac-toe? Well, there I was, lazing the day away watching YouTube, when Mumbo Jumbo uploads a collab video with MatBatWings about computational redstone, where he was tasked to make tic-tac-toe with parts that Matt had prepared for him. So I thought that was cool, but then later on, I see Matt's video where they made chess.com in Minecraft, where 2 players would have a client computer connecting to a server using wired redstone connections. You see where I'm going? I was talking to a friend about this, and I thought to myself, hey, wait, wireless redstone exists. Surely it's possible to make chess.com, but like fully wireless, so the players don't even have to be near each other, like in real life. But I am not up to the task of making chess. So then I remembered Bumbo's video and thought, well, I can do tic-tac-toe, and that's where it started. I hopped onto a creative testing world, started tinkering with tic-tac-toe, and didn't go far, because I had no experience with redstone lamp displays. So then, obviously, what I did was I yoinked one from MatBatWings. This was the one that he showed Mumbo in Mumbo's video, so I just stole it for a second. Don't worry, I made my own later. And then finally, I got this tic-tac-toe board prototype where I could use binary inputs to place X's and O's on the screen wherever I wanted. So let's say I wanted to place an X in the middle. I'd flick this lever, this would make it an X, and then to go in the middle, I'd select that, and I'll explain this all later, and then I'd press this button, and it should pop up now on the screen as an X. After finally understanding how I wanted to do all this, I decided to compact some of my redstone a bit, add a nice little UI so that the player can actually input their plays, and then have our on-off switch and all that stuff, and a reset button. Very nice. But yeah, that's where I called it for a day. And then I came back the next day, and I decided that this was terrible. Like, there were so many problems with the design. First off, the same player could place things wherever the hell they wanted. So I could do that, and then also that. And then it messes up because I pressed the buttons too quickly. Like, not great, not great. This design was not great. So I would not stand for this. So I made another design. A lot of the bulk from the previous design came from the part which I stole from MatBatWings, you see. Like, that's taking up half of the length of my redstone circuit back there. And this makes sense, Matt, being the computational genius mastermind that he is, does not use stuff like pistons or observers or droppers to compact their redstone, because when doing computational redstone, those things can get very annoying very fast. But I'm not a computational Minecraft redstone. Therefore, pistons are on the table. Let's go! Here's Matt's display, and here's mine. They do the exact same thing, but mine is way smaller. You see, the way Matt's works is that you can use this lever to determine whether you want an X or an O, and this lever to lock the thing in. So right now it's an O, and it doesn't matter what I do here, it won't change. But if I turn it off, turn that on, and then turn that back on, it's now an X. This does the same thing as that. So I can put this in, and it won't do anything. It won't change the result. But if I do that, that locks it in as an O. I now can't change this at all. But if I turn that off, turn that on, turn that back on, it's now an X. So they do the exact same thing, but this is 5 blocks wide, and this is not. Now that I have my display figured out, I need to actually figure out how to put stuff on that display. So I used 5 bits here. Each of these blocks represents 1 bit. So we're going to use binary inputs. So I use 2 bits here for the X position. So here, X position 0, 1. So that's when this bit is deactivated and this bit is activated. So anything on this column, because all these have X equals 0, 1, X equals 0, 1, X equals 0, 1. All these, this entire column is determined by this being off and this being on. Similarly, this column, X equals 1, 0, requires this bit to be on and this bit to be off. And then this final column here, X equals 1, 1, requires them both to be on. Similarly, for the rows, we have the pos Y, also encoded by 2 bits. So this is Y0, 1, Y1, 0, and Y1, 1. And then we also have our red bit here for the X or the O. That just determines what the shape of the thing is. But how do I turn those bits into an actual position on the board? Like, conceptually, I know that 1, 0 for the X and 1, 0 for the Y would code for the middle section on the board. But how do I do that with redstone? You see, it's lots and lots of AND gates. I have an AND gate here for the rows, so 3 AND gates for each row. No, 1 AND gate for each row, 3 total. And I also have some more AND gates here for the column, 3 AND gates per column. So 9 AND gates plus another 3, so 12 AND gates total. It's a lot of AND gates. And essentially, the way I do this is that if I were to activate this here and this here, so 1, 0, 1, 0, this should code for the middle of the board, you'll see that our middle row here, the redstone torch turns on. This one's off, only this one's on. Comes along here, and you see that this redstone torch is on because these comparators are no longer depowering it. All the other redstone torches, they're off, but this one is the only one that's on, and this will light up this cell of the board. I can then use an SR latch coming off of this to actually lock stuff in on the board, and then I can disable those when I want to reset the board later. Anyways, now to determine whether or not the board should be X or O, I use this little circuit over here. So when I power this lever, the composters come up and the comparators turn on. That tells the system, hey, we want an X. So the next thing you put in, that's going to be an X, okay? It's going to be an X, not an O, blah, 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 blah. And if I keep that off, that's saying, okay, next input should be an O. You know, makes sense. Hooking up our wireless redstone receiver to the system, along with some other components to make sure the signal is processed correctly, I can now wirelessly transmit a string of 5 bits plus 1 if I want to reset the board. So let's see over here, I want to put something up top there. So I want to put, let's say, a cross in the top middle cell. So I want a cross, so obviously put that down. So 1 there means cross. And for the top there, I want 1, 1. So this is actually backwards. So this is actually the left bit and this is the right bit. So 1, 1. And then for the middle column, I want 1, 0. So since it's backwards, this is going to be the first one, this is going to be the 0. And I put that down by accident. That's fine. And then we'll activate that like so. And that should put something right in the middle there, should be an X. There we go. And then if I want to reset the board, I just need to put this one down, activate that, and that goes through and resets the board. So now that the bulk of the project was done, all I needed to do was add a nice UI so that players could actually put stuff in without having to think in binary. I locked the inputs, so once the input goes through, these blocks will go up, which means that they can't put any more inputs in. And yeah, that was basically wireless tic-tac-toe in Minecraft completed for like the 50th time in my head, because I've done a lot in this testing world. Anyways, that's all for my explanation of the game. I will go over how you should be building this in your Minecraft servers if you choose to do so. But I'll leave a link to my Discord below where you can find the schematics and the world downloads for all this stuff, so you can explore this redstone for yourself. Oh, and just one more thing to add. So wireless redstone is a bit inconsistent in single player worlds, just because there's some bug report that messes with how entity IDs work. I'll leave that bug report in the description. You can go vote on that if you'd like. But yeah, don't do wireless redstone in your single player worlds. It won't work. It really it will work a bit, but you'll get a few misfires. You'll get a few mishaps. It's not gonna be fun when that happens. Okay, so yeah, that's basically it. So if you want to build this TicTacToe machine in your Minecraft server, what you're gonna need to do is grab the schematic, like so, put it down wherever you want it, and then once you build it, you want to come over here to these repeaters, set up the right IP. So for instance, this IP is already at 1111, so I actually want this one to be something different. Let's say 2111, and I want this to transmit to 1111 because that's the machine I'm going to be playing against, right? I'm going to come over here, and this is 1111, and then I want to transmit to that IP, so 2111. Alright, so make sure your IPs are set properly. So just a reminder that that bottom part should transmit and be the same as that top part, and this bottom part should be the same as that top part there. Alright, and one more thing, these daylight sensors and these ones here, they all need pure skylight access. So this block is fine because that's part of the actual redstone, but above this, they should all have access to the sky. And once again, this will only work in the overworld. It won't work in the end. It won't work in the nether. If you've got some custom dimension that has daylight cycles in it or something, that might work. But for vanilla Minecraft, this will only work in the overworld. And that's done. That's done. You're done. You've built the machine. You don't need to like chunk align it or anything. It might be nice if you want to, but don't worry about that. Anyways, that's all for building the thing. I hope you enjoyed this video. I had a lot of fun designing this contraption, putting together this video. So I'll definitely try to do stuff like this in the future, should my life allow time for it. Maybe next time I'll be making wireless Connect 4 or something. I don't know. But that's all for now, so I will see you next time. Goodbye.